This is the third question on the mock test. An airplane lands and slows to a stop uniformly over a distance of 410 meters. The final velocity is 0 because it stops. The initial is 84 meters per second. All right. So the displacement is 410 meters. Initial is 84. This one's 0. And then it says, what's the average? What's the average of 0 and 84?
42.
Yeah, there you go. Yeah. So A, the average is 84 plus 0 over 2. B says, can we keep it down to a low roar? B, what time was the plane on the ground? Oh, okay, I think I know. I think you can use this one. X is 1/2 VI plus VF times T. Right, so 410 is 1/2 84 plus 0 times T. Right? So that's really, it's just going to be 410 divided by 42 is what it is. 10 times 2 divided by 84. 9.76. And then C says, what was the velocity of the plane when it was halfway through at 205? So now we've got to redo this, right? I'm going to set up another one of these. This is for C. So now we just say that X is 205. The initial is 84. The final is what we want to find, and the acceleration is, we don't know the acceleration, do we? We don't know the acceleration. We need the acceleration. Let's figure out the acceleration. Okay. So let's do that. Let's see, how can we do that? I'm going to use the time here, right? And I'm going to go A is change in velocity over time. So it's negative 84 divided by 9.76 seconds. Yeah, well, I think to do it, we need the acceleration, right? Divided by the answer I just got. So the acceleration is, and this is, they don't ask for this, negative 84, 8.60487. Right, so now we can use that. Right, and now we're set. Now we can use V final squared is V initial squared plus 2AX. So V final squared is 84 squared times. Which is? 9.76. It's just a coincidence. Okay, so let's try this. 84 squared plus 2 times the answer I just got times 205. And then square root of that. Whoops. $59.39. Did you find the acceleration? Yeah. So boys and girls, class. You're standing in front of my camera. Okay. On the number 3, And this is just like it. In fact, on the test, I'm pretty sure we ask you what the acceleration is, so you have that number, right? But I noticed on the mock test, it's harder because they don't ask you what the acceleration is. You've got to find the acceleration. So once you have the time, you can use VF is VI plus AT. I just did minus 84 over the time. That gives you the acceleration. Now, at 205 meters, the initial velocity is 84. Final is what you want to find. You have to have the acceleration, right? With that acceleration, you can get the final velocity like that, okay? Now, what does our velocity graph look like for this guy? This is D. What does velocity look like? We start going 84. What's our final velocity? What's our final velocity? No, that's halfway down. What's the final velocity? What is the airplane doing? 0. There we go. What does it look like between here and here? Straight line. There we go, right? Draw a nice straight line. How about position? This is D, position, right? We do X versus T. What does it look like?
Same thing. Straight line.
No, because when it accelerates, it's it's got to be a curved line, right?
Right.
And which way is it curved, up or down? Well, we know it's a negative acceleration, so it's a downward curvature, right, somehow? Yeah? So what does that look like? I think it must be, does it look like that? Yeah, it's moving fast to begin with. Final velocity 0. Yeah? What does speeding up look like? If the airplane, instead of slowing down, it's sped up, what would it be? Yeah, it goes up like this, right? Speeding up is like, right? The velocity graph would be like, right? So this is speeding up. This is slowing down. This one is slowing down. This one is speeding up. Yeah? So the answer to this question is this. But if on the test they ask you something about an airplane taking off, whoops, this is the right one for the test, for the mock test.